we're going to go ahead and start Chapter 8. Chapter 8 is the beginning of inference, which is what we're going to be, we're kind of starting the next chapter, the next section of content from now until, honestly, right before the AP exam. So for the next several months, we're going to be working on inference, okay? And I've kind of alluded to what inference is all year, and it really is kind of half of our curriculum, which is why we're getting ready to do it for the next few months. But what inference is taking sample statistics, analyzing it, conducting tests, creating confidence intervals, which we're going to talk about today, and making some hypotheses, making some conjectures about the general population. Okay, so that's really what we're going to be doing. We're going to actually have some ways to say, based on my sample, I can say this is true about the population with a certain amount of confidence. So there's different kinds of tests. I think we're going to go over 8 of them. And they deal with means, they deal with proportions, they deal with one sample, they deal with 2 samples, they deal with matched pairs. There's all different kinds of different tests that we're going to do. And we're going to do them kind of one at a time. The hardest part is knowing when to use what tests when we get to that phase. We're not going to get there towards the end. We're going to kind of do them all, and then I'm going to put them all together and say, which one do you do? So that's kind of where we're going to, how the process is going to go for the next few months. We're going to start with confidence intervals, and that's Chapter 8. And then Chapter 9, well, Chapter 8 deals with just confidence intervals. And then Chapter 9 deals with a second part of inference. So we're going to combine both of those together for our next test. You will have a quiz just on Chapter 8. I believe that's what the assignment sheet says, right? A quiz on, quiz on sections 8.2 and 8.3. You will see that those 2 quizzes are right at the end of the quarter. They're not going to go on quarter 2. They're going to be the first grades of quarter 3, second semester. So the quiz that you just took and the assignments you just turned in are the last grades of the semester for our class, okay? Just FYI. Yeah, it's back by the desk. If you didn't pick one up, it is for Chapter 8. Just go ahead and grab one of those if you didn't do that. On the back of your assignment sheet, you'll kind of see some things to fill in. You can fill them in as you go, or it's kind of a nice review towards the end. Do you know what all of these things mean and how to fill them in as kind of a review for your test? So we can go over that on test review day or quiz review day if you would like, but it's kind of know that is kind of some guided notes, maybe? I don't know, guided review, maybe that's a better way to say it, that you can look at prior to the quiz or test. Sound good? You ready to get started? All right. How was the quiz, by the way? How'd you think? The quiz test to Chapter 7. Not that bad? I like not that bad. Anyone think they got over 100? A couple people probably. All right, that's fine. You don't have to call yourself out. Let's go ahead and get started, okay? Let's talk about what we kind of have been doing this a little bit all along. You just didn't know what it was. We're going to be able to, after today, hopefully, and it depends on how far we get, because the quiz took a little longer than I anticipated. But we should be able to first define what a confidence interval is, okay? Being able to interpret a confidence interval, describe how that confidence interval gives us a range of values for a particular parameter, plausible range of values. And then we have to talk about the conditions that are necessary, kind of like we've already done those conditions, haven't we? The n times p is greater than 10, the n times 1 minus p is greater than 10, those kind of things. We're going to talk about those and how they apply to the confidence intervals as well. And then there's going to be some issues, and we might not get to those today about how they can affect interpretation. But I'd like to start with you guys talking to each other. So we just took a quiz, so I want to take a few minutes for you to kind of talk to the people around you. And let's look at this scenario, okay? Let's say that, for giggle's sake, I just kind of created some mystery value. I'm going to call it M. And I want you to work with the people around you. And I did divide us up into, I took our groups away, and I apologize, but it was quiz day. But I want you to try to estimate what you think the value is. At least give me a range of values that you think it could be between, okay? So I'm telling you that I went ahead and did this command on my calculator. I did a mean or an average of a set of 16, so sample size is 16, right? Sample size of 16 with the mean M and a standard deviation of 20, okay? And I went ahead and found that average or that mean, and I got 240.79, okay? So that is like, pretend like that's one of those dots back there. It's an average of 16. Do you agree? Okay, good. So what I want us to do is I want you to try to determine what a reasonable set of values would be to kind of capture what the real population mean is. This is a sample. Do you agree? That's a mean of these samples, right? I want you to try to figure out what could possibly be the actual mean. Can't figure out exactly, but maybe a range of values. All right? So I'm going to pause the recording. I want you to talk about it for a couple of minutes. How would we figure that out? Your hint is standard deviation plays a key. Okay? Sample size plays a key. Go ahead and talk. So another hint is, can you be 95% confident that the range you get captures what I'm saying? That's your next hint. So I'd like to have a couple people, if they don't mind, share the range of values that they got. Anyone have an idea of what they got? I'll go ahead and just write them down here. Did anybody get a range? All right.
What we found over here is we found that the standard deviation should be like 5, and then whenever you said 95% confident,
All right, so hang on. So it was originally you divided by the square root of 16, so you got 5. I agree. Keep going.
And so we thought whenever you said 90, we wanted to be like 95% confident.
Because it's normal distribution. The population's normal. Keep going. Did you do that? You added 2 standard deviations and subtracted 2 standard deviations. So in other words, you had a normal population. I love the question over here. Where should we center it, right? Because normally you put the population mean in there, right? Okay, but we don't know that. We're trying to estimate that. So right now we're just going to center this at our sample, okay? So whatever statistic we found, and we're going to add 1, 2 standard deviations above and subtract 2 standard deviations below. And it's the new standard deviation because we're talking about the sample size of 16, correct? So that's exactly what you do. And I think you get like 230 to 250 or something like that. Is that what you get? I think so. It's exactly 5, so I think it was 0.79. It's like 230.79 and 250.79. All right. I think that's what you should get. All right. We're just adding 10 and subtracting 10 because you're adding 5 twice and subtracting 5 twice.
Would it be bad to go 3 standard deviations?
Well, so I love this question. Would it be bad to go 3? Well, how confident would you be if you went 3? 99% confident, right? And so that really comes into play as how confident do you want to be, okay? The general rule of thumb is to use a 95% confidence unless told otherwise. Sometimes we do 90%. Now, we can't use the empirical rule for that. There's a different thing, and we'll talk about what that is. But for 95%, this is a pretty good estimate of what we're trying to capture. Now, what's important to note here is that this number here, 2, is really not an arbitrary number, but we came up with it because of the empirical rule. Do you agree? That number was given to us because of that. The actual exact value is 1.96, and we'll talk about how we get that value next class, okay? But this is a good estimate just because of the empirical rule and what we're comfortable with. This is actually the formula. Well, I guess we'll get to the formula in a minute. But all right, feel good about what we're talking about so far? I want to jump ahead, and I shouldn't. All right, so this is just kind of the explanation of what you guys just did. You did it, so yay for you. Good. 99.7 rule. This is just, we already had this conversation. Perfect. All right. So if you look at your formula sheet, if you happen to have them still on your desk from earlier in the class period, I believe it's on the top right column. I have talked to you about how your formula sheet won't be in columns, but each of these will be its own page, right? I just condensed it to one page. I don't know, just page 3 of the formula sheet. You should find something along this lines for confidence interval. Do you see that? Okay. Estimate. What kind of things can be used for an estimate? Point estimate or a statistic? We just came up with one. We just used one. We used X bar, right? It was a sample mean. What else could you use? P hat, right? So when we talk about the point estimate, we're either looking at X bar or P hat. Just depends on whether we're talking about means or proportions, right? Whatever our sample is that we're using, okay? So it's a sample statistic. Does it say the word estimate on your formula sheet, or does it say sample? It says statistic. So it doesn't use estimate on your formula sheet, it uses statistic. Do you see that? Right? Okay. And it probably talks about what the margin of error is. Error is the critical value times the critical value, by the way, that we just came up with was 2, right? 2 standard deviations above and 2 standard deviations below, because that number is associated with 95% confidence, right? Critical value, and then it's times. I want to make sure I'm using the right language. So the standard deviation of the statistic, which would be p hat or mean. Would you agree? Good so far? All right, perfect. So critical value, we're going to learn how to find that exactly. Often it's called Z star or T star, depends on whether you're using a normal distribution or whether you're doing a different distribution, which we'll talk about later, it doesn't matter. It's called T distribution, but we usually choose a confidence interval of 90% or higher. The most common ones are 90, 95, and 99. Okay? The most common is 95% confidence, and it's to be assumed unless said otherwise. Fair enough? Okay. So, what does this range of values actually do? If I find it, what are we trying to capture? Anyone? All right, I didn't think I'd stump you on that question. So between the 230 and the 250 that we found in my fake example, what were we trying to make sure? We were 95% confident that what was inside that range of values? The population parameter, right? So what we're trying to do with the confidence interval is use our sample statistics to try to capture we're 95% confident that the real mean is between here and here. Okay? So what does that look like over time? Well, I really like this picture, and I'm going to turn the lights out so you can see it a little bit better. But the picture on the right-hand side, the dot, happens to represent the sample statistic, the X bar or the P hat or the whatever, okay? And then we just added and subtracted however many standard deviations on either side. Are we okay with that? So each of these little lines represents a confidence interval. Why do you think they're not all the same? Why do they kind of move around a little bit? Well, aren't our actual means that we find going to be different? Right? They're going to be different every time, aren't they? I mean, think about those dots. Are they all exactly in the same spot? No. So they're a little bit different every time. But they're all kind of, then we have this oddball. Is that okay? Well, sure, every once in a while you're going to get an outlier thrown into your mean that's going to drag it to that particular side. Do you agree? It's not all the time, but it happens every once in a while. But what this vertical line represents is the true population parameter. So 95% of the time, that range of values captures it. Every once in a while, it won't. That's why you have to have a percent of confidence associated with what you're doing. Make sense? On like a upper level, maybe, hopefully? All right. This sentence that you see here, you can either copy it down or you can just print it off of the notes from the website. But you have to write a sentence. It's my favorite thing, right? Write a darn sentence to explain what you're talking about. But whenever you see the word the phrase interpret the confidence interval, you hear the words interpret, you have to write this sentence, okay? So to interpret a confidence interval, we say, quote, we are 95% confident that the interval from whatever numbers you came up with captures the actual value of the NFL salaries, the true mean of the NFL salaries, okay? But context is key. Again, you can plug and chug, yes. What's in quotes? Yes, we are. And see, this means whatever percent confidence we're using, right? We are 95% confident that the interval from whatever numbers, 250 to 280, captures the actual value of the mean you made up, Mrs. Mackert, whatever. You know, Mackert's mean, M. So again, you see the words interpret, you got to write that sentence, okay? Any questions so far? All right, good. This particular section 8.1 is kind of, I hate to say fluff, but there's not a lot of there's not math in it yet. It's coming. I say that, but this is still math. It's just not calculations yet. That's 8.2. All right, so the confidence level, when we're talking about interpreting confidence intervals, does not tell us the chance that we've captured it. It tells us how confident, it tells us that it just gives us a set of plausible values. We can't say that it's 95% likely that we've captured it, right? So make sure that you be careful of your wording there. I've seen AP get real picky about the wording, okay? It's a level of how confident we are that it's in there. It's not a chance of likelihood that we've captured it. Okay, good. All right. We've already done this too. This is our general form, which is what you have. The critical value, we're going to start with proportions, and it's an actual z value. We call it a z star because when it's got a little star by it, that means the critical value. There are a set of critical values that are associated with each confidence interval level, okay? And we'll talk more about those when we get more delved into it. But like I said earlier, the 95% confidence z star would be 1.96. And we'll talk about how we calculate that next class, okay? I can see a question possibly being, when we get to that point, what would the critical value be for a 92% confidence interval? And we'll talk about how to find that, okay? Good. All right. I want to make sure that I don't miss anything. Okay. These two things down here are kind of important for us to kind of talk about down the bottom right. First of all, the margin of error is what you are adding or subtracting. It's the critical value times the standard deviation of your statistic. It's what you're adding or subtracting on either side. The margin of error is half the width of the interval because you're adding it and subtracting it from the statistic, right? So the margin of error, how does it get smaller? Don't we want to if you think about it in general terms, we want to have the smallest interval possible because we can be 100% confident that your grade is in the range of 0 to 100. Would you agree? Well, maybe 110. There's people in here who have over 100. But I can be 100% confident of that. Would you agree? Okay? But that doesn't really help us. That doesn't give any detail about what's happening in this class. So we want to try to decrease the size of our margin of error. So as our confidence level decreases, the margin of error gets smaller. Doesn't that make sense? I'm 100% confident between 0 and 110, but I might be 50% confident that it's between 80 and 100. Would you agree with what I'm saying? Okay. So as your confidence interval decreases, the interval gets smaller. And this is also important. As your sample size increases, the margin of error gets smaller. Okay? And we'll talk about why that happens. Well, actually, we can right now. Doesn't the standard deviation depend on the sample size? Aren't you dividing by n, whether you're talking about means or standard deviations in either case? Sorry, means or proportions in either case, you're dividing by n. So as your sample size gets larger, you're dividing by a larger number, which means you're going to get a smaller standard deviation, right? Which means you're going to get a smaller interval in general. All right, so that's a quick overview of the beginning of confidence intervals. You should have enough information to be able to answer the first set of questions. We do have a 3-day weekend, woohoo! So, yay, enjoy.